Hello everyone, this video is the last video for lesson number 4, including the unit number 2, which is on angles. We are still going to talk about the angle pairs formed by a transversal line, specifically if the lines cut by a transversal are parallel lines. Again, we only need this claim so that we could actually establish relationships that could actually turn into equations and help us solve the value for the intended variables here. If we don't have this, then we cannot solve any of this. So if we have this claim, we can now determine the relationship between the angles here, specifically the angles having the variable x, this area, and this area here. Why do we have to consider these two angles here and not instead of angles y and z? Take note that in number 1, we are solving for the value for the variable x. And we can only use an equation dealing with a variable x. If we're going to relate this angle with angle z or angle y, we might come up with an equation having two variables and would cause us two confusion and give us more trouble in solving the variables. So we are going to look at an equation that could actually include the measurement of this angle and angle here. To do that, we need to first identify the type of angle pair formed by these two angles here. So we have 5 pairs of angles formed by a transversal. We have corresponding angles, alternate interior angles, alternate exterior angles, same side interior, and same side exterior angles. With these two angles in consideration, we are going to scrap now the same side interior and the alternate interior angles. Why? Because as you can see, these two angles are found on the exterior. None of them are found on the interior. That would mean we are going to scrap those two. Aside from those two, we cannot also call them corresponding angles because corresponding angles must have one of the two being on the interior. But since both of them are found on the exterior, we can only use either alternate exterior angles or same side exterior angles. To determine the correct pair of angles here, look at the two given angles. They are found on the same side. So by the term same side, these angles, the two angles here, are forming a same side exterior angles. And by identifying that they are forming same side exterior angles by the claim that that line lines E and F are parallel lines, we can use the relationship of their measurements given to us by the postulate and the fourth theorems. But specifically, we are going to use here the same side exterior angle theorem. Why this? Because then again, we are sure that they are forming same side exterior angles. So we could use here the same side exterior angles to come up with an equation. And what would that equation be? The same side exterior angle theorem tells us that if a transversal cut two parallel lines, then the same side exterior angles are supplementary. If we say supplementary, the sum of their measurements yield to 180 degrees. Again, do not be confused with the previous videos talking about congruency because they are actually true to corresponding angles, alternate interior and alternate exterior angles. But for same side exterior, similar to the same side interior, it's not anymore congruency or having the same measurement. It is now supplementary or summing up to 180 degrees. And what should be summed up? These values here. So if we're going to add them up, x plus 28 degrees plus x minus 4 degrees must yield 180 degrees. This is again given to us by this theorem. So if we're going to add them up, they must up to 180 degrees. And notice that we only have the variable x here. We can solve now item number 1 by applying the properties of equality. This would actually become 2x as x plus x. We resolve to this, and then that's plus 24 degrees must be equal to 180 degrees, right? So subtract both sides by 24 degrees. So we'll have here 2x is equal to, subtract here 156 degrees. And then if we're going to divide both sides by 2, the value of x becomes 78 degrees. Do not be too confident with this first because you might have created a little bit of an error. We need to check this. And by checking, we need to use the equation here brought about by the theorem. So substitute 78 degrees plus 28 degrees plus another 78 degrees but minus 4 degrees. Will it yield, question mark, to 180 degrees? Let's see. 78 plus 28 is 106 degrees plus 78, that become 184, minus 4, you will have 180 degrees is equal to 180 degrees. This would mean that the value for x here is correct. Another checking that you could do here is by using the value for x in getting the values of each of these, and let's see later on if they are actually supplementary or not. So the x plus 28 degrees will become 78 as it's the value of x plus 28 degrees, and that would become 106 degrees. And for x minus 4 degrees, x being 78 degrees minus 4 degrees, you will have 74 degrees. Look at the values of the two, 106, 74. If you're going to add these two, will it become 180 degrees? The answer is yes. And since they could sum up to 180 degrees, they are supplementary, and we have satisfied the claim of the theorem, being the lines cut by transversal to be parallel lines. Okay. So this is actually the first step in solving this problem. We have now solved the value for x. To solve for the remaining values, we just need to simply look at the relationship. Let's talk about number 2 of angle y to any of the angles containing variable x. Again, why do we always refer to an angle with variable x? The answer for that is if we are going to relate this to any angle with variable x, and since x is already given earlier, it's easier for us to solve for the unknown. But if we're going to pair it with, say, for example, z, we will end up with an equation having two variables, and that's a problem. So let's talk about the relationship with this angle and the angle here. To understand their relationship, you may actually use the previous angle pairs in the previous lessons, specifically the linear pair, the angle forming a linear pair, and the the vertical angles rather. For this figure, angle y and this angle which measures x minus 4 degrees are forming vertical angles. And by vertical angle theorem, which tells us that the vertical angles are congruent or having the same measurement, we may equate the value of y, same measurement, e- equal to the value of this angle here, which is x minus 4 degrees. And then, yes, you do have two variables, but one of which is already solved in number 1. So that's your first process. You may substitute it here, or x minus 4 is already given here as part of the checking of number 1. That is why we added this form of checking because this could actually help us in answering number 2 and definitely number 3 later on. X minus 4 degrees is 74 degrees. If you're still going to substitute the value of x here, you will still get the same value. So might as well simply use that immediately. So y will become the value of x minus 4, which is 74 degrees. Okay, that's the answer for the value of y. As for z, we may use the relationship of y and z. But if we have committed few errors in solving for the value of y, we could actually bring that error in solving for the value of z. So let us not use that. What we could use here is to pair this angle z, or this variable, this angle with variable z, to an angle with the variable x. And I'm talking about this angle here. Earlier, this angle and angle y are forming vertical angles. But for number 3, specifically for angle z, and the angle which measures x minus 4 degrees are forming a straight line here, and thus they are called to be angles forming a linear pair. And by linear pair postulate, we could add their measurements and equate to 180 degrees, because linear pair postulate tells us about angles forming a linear pair are supplementary or sums up to 180 degrees. Again, let's try to differentiate, okay? Vertical angles, congruent, that's part of lesson number 2. Linear pair, angles forming a linear pair are supplementary, also part of lesson number 2. So again, angle Z and this angle, which measures x minus 4 degrees, are angles forming a linear pair. Thus, if we could add the two measurements, that's Z plus x minus 4 degrees, they should yield to 180 degrees. And then we could just simply again use the value here for 74 degrees, or again use the value of x. But since we do have this, let's use that. So z plus x minus 4, which is 74 degrees, must sum up to 180 degrees. And then apply properties of equality, specifically the subtraction property of equality. Subtract 74 degrees on both sides. That's orange. So z is equal to 180 minus 74. That's actually 106 degrees. So these are the values for z and y using the variable we have solved earlier for x. But again, before in solving for x, we need to come up with an equation pattern to any of those one postulate or four theorems upon deciding the type of angle pair, and with the claim that the lines cut by a transversal are parallel lines. The other way of checking number 3 is by looking at the relationship of z, this one here, and this angle here. This is by long shot considered to be alternate exterior angles. And by alternate exterior angle theorem, they must have the same measurement or they're congruent. So x plus 28 is already given to be 106 here. That is also the value for angle z dito. Okay? So there are actually plenty of relationships for angles formed, angle pairs formed. But I just simply use here the easiest under vertical angles and linear pair postulate. But then again, I would like to caution you, these are all possible with this claim and the proper identification of the statement to come up with the equation. So to do that, you simply need to practice, look for other examples, look for other references, make your own problem, solve it, practice and practice. Use this video as part of your review as we have our assessment later on. Thank you very much. Goodbye.